Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 9, Section 3, Transformations of Quadratic Functions. So our Section 2 was a very short lesson, and Section 3 will be a short lesson as well. Okay, so why? The reasons that the parabola is shown at the right, the graphs of the parabola shown at the right are the same size and shape, but notice that the vertex of the red parabola is higher than the y-axis than the vertex of the blue parabola. So the vertex is here and there. So the red one is higher than the blue one. Shifting a parabola up and down is an example of transformation. Okay, transformation, just transforming the shape, or the graph in this case. So translations. So you might have learned translations in pre-algebra, and you will definitely learn it more in geometry. But transformation is changes the position or size of a figure. So anything that changes in position or size or figure. One type of transformation is called a translation. Okay. So translation is really when you just slide. Okay. Translation is when you just slide. This figure moves the figure up, down, left, or right. Then a constant c is added to or subtracted from the parent function. The graph of the resulting function f of x, plus or minus c, is the graph of the parent function translated up or down. The parent function of the family of quadratics is f of x, x squared. All other quadratic functions have graphs that are transformations of the graph f of x, x squared. Okay. All right, vertical translation. So if you're sliding up or down, the graph of g of x, x squared equals x squared plus c, is the graph of f of x, x squared translated vertically. So if c is greater than 0, the graph f of x equals x squared is translated absolute value of c units up. If c is less than 0, you go the absolute value of c units down. So if you have green is the parent function here, okay? If you're adding a number, the y-intercept, if it's positive, you're adding up. If it's negative, you're just adding to down. You're just going down. All right, describe and graph translations. Describe how the graph of each function is related to the graph of f of x equals x squared. Okay, so here you have the original x squared, and you're adding 3. So from the green, which is function of x, okay, here's the original, okay, and function of h of x, you went up 3. It's the same graph, you just go 1, 2, 3 up, and you just slide it up in the exact same graph, you're just sliding it up. Positive 3 means go up. For here, g of x, x squared minus 4 is the same thing. There, green is the original one, okay, x squared. Minus 4 means you just slide this graph down 1, 2, 3, 4. You're just moving it down here, and it's the same graph. All right, here's your turns, numbers 1a through 1d. So describe how the graph of each function is related to the graph f of x, x squared. So started here. What did you do for each graph? Okay, did it slide up or slide down? And you don't say slide, you say translated. If you want to go back, it says the value of c is 3, therefore the graph is translation of the graph up 3 units. So here you can say translation of the graph, translation of the graph f of x equals x squared, 7 units down, okay, since it's a negative 7. Okay, so there's your answer for 1a. So go ahead and do 1b, 1c, and 1d. So pause the video, Go ahead and do that. Make sure you write the answer for 1A as well, just like this, and then come back when you're done. Alright, welcome back. Dilations and reflections. Another type of transformation is called dilation. Okay. Dilation makes the graph narrower than the parent graph or wider. So now it's not just shifting up and down, it's now the actual curve is going to get wider or narrower. That's called dilation. Okay, that happens when it's multiplied. The parent function x squared is multiplied by a constant a. So now you have not just x squared but ax squared. Okay. In this case, when your a is the absolute value of a is greater than 1, then it's going to stretch vertically. So it's going to stretch. If you have between 0 and 1, then it's going to be compressed vertically. What does that look like? Alright, so here, your graph f of x, x squared, okay, is the blue. Your original is blue. So this 1/2, okay, that number is, that a is actually greater than 0, but less than 1. Okay, so when you have a number that's less than 1, okay, but it's still a positive number, it's greater than 0, then it's going to stretch out more. Okay, so the red here, you see it's stretched out. When you have a that is greater than 1, then it's going to be actually narrow. So here's the original graph, x squared. So if you have 3x squared, it's going to be smaller. And then you notice here, you actually went up 2 as well. So from this original graph, you went up 2, and then it got narrower. So it's slimmed down. Okay. So if this a is bigger than 1, it's going to slim down. Okay, go ahead, do 2a, 2b, 2c. Okay, compared to parent graph x squared. So did it get narrower or wider? Okay, did it shift up and down, up or down? So go ahead, do those 3 problems and come back when you're done. Alright, welcome back. Now we'll move on to reflection. A reflection is just like a mirror, like you see a reflection. A reflection flips the figure over a line. It's not changing anything else, it's just flipping up. Imagine that as a mirror, it's just showing the reflection. Okay. So that happens when your parent function x squared, or the variable x, is multiplied by -1. So you have here graph of excuse me, negative f of x is the reflection of the graph of f of x, x squared across the x-axis. If you have a graph of f of negative x, reflection of f of x is x squared across the y-axis. Okay, so reflection can be across the x-axis or the y-axis. Alright, example. Describe the reflection. Alright, so here you have g of x, -2 x squared minus 3. And how is that related to f of x, x squared, the parent function? 3 separate, excuse me, 3 separate transformations are occurring. The negative sign of the coefficient x squared, this negative here, causes a reflection against the x-axis. So if this is the x squared, okay, it's going to reflect upon the x-axis because there's a negative here. Then a dilation occurs. Okay, so this number here, okay, made it narrower. Okay, and then finally it went 3 units down. -3 means go down 3, 1, 2, 3. Okay, so 3 things happened here. It reflected upon the x-axis. Okay, you got narrower, you got dilation, and then translation went down 3. Okay, so that's a lot going on there. Alright, so go ahead and do 3a and 3b. Compare to x squared, the parent function. So you need to describe 3 things if there was a reflection. Okay, it's still difficult to write in this pad. Alright, reflection. Was there dilation? And was there transformation? Translation. Okay, so when you're describing, you need to tell all three of these. Okay, so when you're done, come back. All right, welcome back. Here is a standardized test example 4. Which of an equation for the function shown in the graph? So which of these equation is this function here? All right. So first thing, read the test item. Okay, you know you're given the graph of a parabola because it's a curve. You need to find the equation of the graph. Solve the test item. Notice that the graph opens downward. Remember I said if it's negative, it's going to be a frowny face. So it's not A, it's not D. Okay, so you have two options. It's going to be a negative, so it's going to be C or B. So the parabola is translated 5 units up. So here it's 1, 2, 3, 4, 5. It's a positive 5, not a negative 5. So you know the answer is C. Okay. So go ahead and do number 4, and this is the last slide. So it was a quick lesson here today. So when you're finished, make sure you put in your book bag for full credit for homework tomorrow. And thanks for watching.